All right, let's talk about synthesis reactions in 8.04. For all of these categories, if you're watching this and you're out of class, we're going to do these demonstrations in class, but if you're at home, you know, if you're out sick, I'm going to go ahead and get a video clip for you. So the demonstration we're going to do for synthesis reaction is we're going to take elemental aluminum, so that's solid aluminum, and we're going to combine that with solid iodine. And remember, it's diatomic. So keep in mind our categories that we had before. We said that synthesis reaction was A plus X, going to give us AX. And that kind of is a tip off for what we're going to form. Hopefully you can see. But let's take a look. So what I'm going to do is I'm going to show the video clip and I'll narrate it as we go. And then we'll talk about the products. Screen share. All right, so what we have here is we have powdered iodine and powdered aluminum. And I don't think you can hear his voice. This is a container that has some, just like ceramic in it so that it'll hold the reaction. So he's going to mix it. And he's going to dump it into here. And it takes a little bit of time to start. This dropper is full of water. And he's going to add a few drops of the water just to speed up the reaction. This doesn't have any part in the reaction, it just speeds it up. And we'll just wait a bit. You'll notice he's doing this reaction outside. In the classroom, we have to do it in the fume hood because this purple gas that's being produced is a byproduct. It's some iodine gas, and it's toxic. It could hurt you if you inhaled too much of it. So anytime you see a gas and it's got a color, that's a good warning sign to stay away. But we do this in the fume hood. It's perfectly safe. And you can see this is very exothermic. We're producing a lot of heat. We're producing a lot of light. So back at the beginning of the chapter, we said, what are the indications of a chemical reaction? We said it produces heat, it produces light, produces a gas sometimes. And we have all three of those in this instance. At the end, you'll notice we had a silver powder and almost a black powder to start with. And if you look, if you can see, here we go. That was the product. So I don't know if you can see my cursor here or not, but we have this white powder. Okay. So what in fact we made was aluminum iodide. Now, remember, this is going to be an ionic compound. And we have aluminum. So we're going to have Al and we're going to have I. But we have to write the correct formula. So if you remember, when aluminum iodizes, it forms +3, and when iodine iodizes, it forms -1. So our formula here is going to be Ali3. Well, I'm not balanced, so I have got 2 iodines over here and 3 over here. So let's put a 2 here and a 3 here, and that's going to give me 6. And 6, and then I'm going to need a 2 in front of my aluminum to balance. So that was this synthesis reaction, but that doesn't tell us why. So we said in the last video that chemical reactions occur because of gaining and losing electrons. And we said, according to oil rig, oxidize is to lose electrons, and reduction is to gain electrons. And so what we need to do is we want to look at who got oxidized and who got reduced. in order to analyze oxidation and reduction, you have to compare, it's going to kind of write up here. You want to compare the right reactant with the left product. So I started out with aluminum. Let's do aluminum first. And aluminum on the right is an element. And remember, elements are neutral. They don't have a charge. So we use a 0 to indicate neutral. And let's do iodine in light blue. Iodine is also an element. So that's also going to be neutral. When it ionized, it went into an ionic compound. So we went from neutral aluminum to aluminum +3. And in order to form this ionic compound, these guys had to ionize. So this was the process of ionizing. Iodine went to I -1. Let me grab a periodic table. I'll pause the video. So if I look, I grab my periodic table, and when I look at aluminum, I see that aluminum has 13 protons. So it's also going to have 13 electrons because it's neutral here. So the charges have to add up to 0. If I look at iodine, I've got 53 protons, which means I have to have 53 electrons. There was a change. So what actually we have happening here in the middle is it ionizes. This is the ionization. So to go from iodine neutral to iodine -1, how do we get this -1 charge? Well, this is going to have, if it's got a -1 charge, I added an electron. So this is going to have 53 protons, but it's going to have 54 electrons. That's what gives it the negative charge. It has one more electron than it does protons. How did aluminum get this +3 charge? It has to have, or here's a better question. How many electrons does aluminum have to have if it has a +3 charge? Did you say 10? Over here, I have 13 protons, but now I have 10 electrons. So 13 positive plus 10 negative gives me +3. That's where this +3 charge comes from and the -1 charge comes from. So I went from 13 electrons to 10 electrons. What did I do? Did I gain or did I lose? I lost electrons. Here I went from 53 to 54, so here I gained. So we say that aluminum, lose is oxidized. We say aluminum, aluminum is oxidized and iodine is reduced. That was actually the chemical reaction. It was the gain and the loss of electrons. All right, let's do another one. So if I have magnesium and I'm combining it with oxygen, I'm going to form magnesium oxide. I'm going to have an ionic compound. Well, I'm going to write them way over here so I don't get them confused. Magnesium's +2, oxide is -2. So when I write this, the product, I'm going to have MgO. I've got 2 oxygen here. I've only got 1 here. So to balance, I'm going to want to put a 2 here, which is going to make me put a 2 in front of this magnesium. So who got oxidized and who got reduced? Let's go to, I've got magnesium is neutral and oxygen is neutral. I went from neutral to a +2. Here I went from a neutral to a -2. If I added negative charges, that means I had to have gained. Positive charges means I lost electrons. Here I gained electrons. So once again, the metal was oxidized and the nonmetal was reduced. So we say that magnesium was oxidized. Oxidized, O-X-I-D-I-Z-D, and oxygen was reduced. Now, you can memorize that for these, but what you're going to see is that it's going to change depending on the category of reaction. So I recommend you're able to look and go, okay, I have an element, I'm neutral. Over here, I'm ionic, so I've got a +2. And when I get a positive charge, it means I lost electrons. You're really going to want to be able to work through the process. All right, go ahead and pause the video. And actually, go ahead and do this as a sample problem. Pause the video and do it and come back and we'll see how you did. All right, we've done this one before. I actually wrote this on one of the other papers. But when we combine sodium with chlorine gas, we're going to get sodium chloride. Sodium is +1 and chloride is -1. So when I write this, I get NaCl. Now I need to balance. I've got 2 chlorine on the left, but I've only got 1 over here. So I'm going to put a 2 here. And then the sodium balance out. And once again, I'm going from neutral sodium to sodium +1 and neutral chlorine to Cl -1. So once again, sodium, the metal is oxidized and the non-metal is reduced. Okay, that takes care of synthesis reactions for us. Thanks for watching.